Alrighty, here we are with the pH scale, which is one of my favorites. If you are a math student, I think you learned it in Algebra 2. You learn the log scale, and log scales never made sense to me as a math student, but once I took chemistry, it clicked. So maybe I can even help you out there. Here we go, pH scale. Oh goodness, this bubble is making me nuts. Okay, so pH kind of sort of stands for power of hydrogen. In fact, it actually means the negative log of the hydrogen ion concentration. So the number of the pH, like whatever the pH rating is, that is going to tell us the relative strength of an acid or a base, and that is solely based on the concentration of hydrogen ions, or H+, that is dissolved in the solution. Then we have this right here. The more H+ we have in the solution, the stronger that acid is going to be. And OH-, the more of that we have, the more hydroxide, the stronger the base is going to be. Now, you have acid in your stomach. That is a very strong acid. pH is probably around 1. Vinegar is also an acid, but that has a very small pH, or I'm sorry, a higher pH, but that makes it a weaker acid, and that is because it has less hydrogen ions in the solution. So the pH scale runs from 0 to 14. The lower numbers indicate acids. Those numbers are going to be 0 to 6. 7 is considered neutral, which is exactly where distilled deionized water falls. And then he doesn't respect anything. 8 to 14, those pHs are going to be considered basic, and the closer to the ends of that scale, the stronger the acid or the base is going to be. So here is a picture of the scale. This is indicators kind of sort of following universal indicator, like the colors. More on that later. This region of the scale is acidic. The closer you are to 0, the more H+ is in your solution, and therefore the stronger your acid, which also by default would mean that we have less OH in the solution. At a pH of 7 with in a neutral solution, we have an equal amount of H+ and OH-. And then on this end of the scale from 7 to 14, we have our basic solutions that have more hydroxide than they have hydronium or hydrogen ion. Now, strong bases are going to completely dissociate when they dissolve in water, meaning that 100% of it is going to dissolve. It's super soluble, etc., etc. Those strong bases typically are coming from group 1 and group 2 on the periodic table. Weak bases are only going to partially dissociate, which somewhat has to do with their solubility. Strong acids are going to be ionized completely, meaning that 100% they break apart. They're very soluble. And again, water is considered neutral because it has equal amounts of hydronium and hydroxide. So this is where things get interesting. On a linear scale, which is like the number line back from first grade, we have our scale here. It's very simple. To move up 1 notch on this scale, you would add 1. To go up 2 notches on the scale, you add 2. To go back 2, you would subtract 2. Very straightforward. But on a log scale, things are a little bit different. On a log scale, to move from one number to the next one, you would either multiply or divide by 10. So you can see here, if this were a log scale, to move from one number to the next, we would multiply by 10. To go up 2 numbers on the scale, we would multiply by 100, because each jump would be 10. So it's times 10 times 10, which is the equivalent of times 100. And then to go backwards, we would divide. So in this case, we're trying to go back 2, so we would divide by 100. Now, the equation for pH is the negative log of the hydrogen ion concentration. So P literally means negative, it means log. So this would be on a log scale, but this negative actually flips everything backwards. So this is where things get a little funny. To go up the scale, we divide because this negative sign flipped all of the rules. So over here on the general log scale, to go up, you would multiply, and to go down, you would divide. But because of this negative sign right here, when we go up, we're dividing. So if we go up one number or one section on this scale, we're dividing by 10. If we want to go up 2, we divide by 100, which is really dividing by 10 twice. And then here to go back to, we're going to multiply by 100. So really what this means is that as your hydrogen ion concentration goes up, your pH goes down. So strong acids wind up having lower pHs. So a solution with a pH of 1 is 100 times more acidic than a solution whose pH is 3. Again, a solution whose pH is 1 is 100 times more acidic than a solution whose pH is 3. So the lower the number on the scale, the more acidic, because we have more hydrogen ions. Now, if that's confusing at all, please rewatch the video because this will take you a few times to understand. It took me quite a few years to understand it. You'll be okay because you are a smart chemistry student. I believe in you. So if you have any questions, leave a comment. I will do my best to get back to you.